Okay, we're at the course website. And again, I want to point that out to you. It's mth121, mth121.mathography.org. Of course, this website will be updated. Right now, I'm not completely updated at the time of this meeting. So it over here, I just want to read to you, there's a little video over here. If you need it, you can watch this little video over here about how to use the website. But the bottom line, the website, there's not much here, but I do want to go through it with you. So the first thing it says, you may download and print the notes for free. So if you click on this over here, a link is going to open up. And now they may ask you to join Dropbox. Just say no, thank you if you don't want to join. You don't have to join Dropbox to get access to the notes. There's no charge for the notes either. So these are the notes. I'm just going to expand the window. And you could use this, for the notes. I mean, you could do this and, you'll see me like through semester go through these notes. For example, at some point I'll get to chapter 9 and, I'll be in chapter 9 and I'll be talking through this. It's nice if you have access to the notes, and the notes are free. So there's no real reason you can't have the notes available to you at all times. I would recommend downloading them, and I want to go through that with you. So let me expand the sidebar. And so if I want the notes, what I would do over here, I just expanded the sidebar by doing this, by the way. I'll go through this once again for you. Click on this and just download the notes, and you could download to your computer. All right, let me review what I just did. All right, you may download and print the notes for free. So again, if you click on this, my Dropbox will open. Again, you may be confronted with something saying, hey, join Dropbox. You don't have to join Dropbox. Just say no, thank you. You'll get access to the notes for free. I recommend you download the notes by clicking this over here and download them to your computer. That's what I recommend. Other students will say, nah, I'm not going to bother with that. They just keep it on Dropbox, and you can do that. You'll have access to the notes. What's in the notes? All the material that we're going to cover, right? All the material we're going to cover, right? I'll go through that today, by the way. We're not going to cover all the material today. We're just introducing the material today. We're going to start with a particular section. We'll get to that later. So let me go back to the website. I'm going to close this out. And again, you get access to the notes. You can do that now if you like. These notes will provide structure to the classroom, whether it's virtual or real. What I mean, if it's being done online or in classroom, it still provides structure to what we do in that classroom, whether it's real or virtual. And they shouldn't be used without attending each and every lecture. So you need to attend lecture whether or not you're given the notes to the lecture. So a lot of students, I realize, especially at Essex College, the point of going to lecture is to take notes. Well, I'm bypassing that. I'm actually giving you the notes. What I'm going to be doing is walking you through the notes. All right. This is going to be a bridge between here and when you get to a university where they're not going to give you notes. What they're going to give you is a lecture. The lectures are going to be long and difficult, and you're expected to take notes during those lectures. I'm kind of reversing it, like flipping the classroom. I'm giving you the notes, and then we get in the classroom, I'm going to be talking through the notes, right? Hopefully you understand that process as we go through the course further. These notes include all materials taught and the required written assignments. They're in the notes, and we'll talk about that today, all right? Now over here, I have to update this, by the way, but don't worry about it. I know what you say, it's not there, it's not there. You know what? It depends what's going to be here, but I'll update this later. All right, what's there? Typically syllabus, schedule, links to Zoom if it's virtually done, links to office hours if they're virtually done. All right, don't worry about that. I'll update that later. The other thing is there's a link to WebAssign. If WebAssign is being used, you could use this to get the WebAssign, but if it's being done through Moodle Rooms, you first have to go through Moodle Rooms to get the WebAssign. Otherwise, you'll never get the WebAssign. Okay, here's something over here I want to talk about. These lectures are being recorded, and then they're going to be published online for you to download at your convenience. So you could click on that and download the lectures. Sometimes we'll have archives of lecture from prior semester, but for the most part, they're going to be the same stuff over and over again. Like we covered the same material. All right. tutoring available at Essex County College. If you're interested in it, you click on that. It would bring you to Essex County College tutoring website. I also want to claim over here, you're going to hear me talk about Sage a lot throughout the semester. Nothing to get nervous about. We're going to take you, basically hold your hand through the course one step at a time. But you're going to see me talking about Sage. What's Sage? A computer algebra system. There's a little video here if you want to watch it. Don't feel obligated to do so. I'm going to tell you for the most part, we're going to be holding your hand from here until the end of the semester. But you have to be here for us to be holding your hand. If you're disappearing and not attending class or not participating, there's no way we can hold your hand. But we want to make sure that you're following along. Now, granted, after today, there'll be a lot of hand holding, but there'll also be opportunities if you feel that you've not been dealt with fairly. In other words, the lecture didn't go well for you, and what's being asked of you didn't go well for you. You have the option of reaching out to me for private one-on-one clarification. All right. What does that mean? Office hours. We'll be there for you. All right. Now, of course, go to the bottom of the page. You'll see there's another link over here for students interested in acquiring new skills in Sage, and for students that are acquiring new skills in mathematical typesetting. I wouldn't worry about that, though. What I'd be worried about is, hey, you got a website, you got a link to the notes. So that's what I want to do now. I want to talk about how the course is going to be run. So let me close out my website. Again, that website is mth121.mathography.org. Let me close this out. I'm going to talk about the notes now. This is what the notes look like. And these are downloaded to my computer. I downloaded them. Of course, they're going to change. Like if you look at this one over here, it basically says it was updated April 25th, 2021. They'll be updated throughout the year. I mean, I update notes. When I do, maybe I made a change here. Maybe I delete something. Maybe I insert something. There's some subtle changes over here. So looking at the guide, I notice there's contents. And this is where people get alarmed. They say, oh my God, you're going to cover this? Yeah, we're going to cover it. We're going to cover everything. Right now, so that was too much for me. I just can't. If you give me more than 3 pages to think about, I'm not going to get there. Well, here's the deal. We're going to go one page at a time, and we'll get through it. Believe it or not, we will get through this. But I'm not going to say in a day. It's going to take a semester, and we're going to get through it. How do we do it? We start at the beginning. So what are we going to do? Where's the beginning for this course? Well, the beginning, it might vary from student to student. There are obligations you have on your end. We are expecting that you've actually taken a course at Essex called Pre-Calc 1, Pre-Calc 2, that's 119, 120, did well in that, measure the material. What I do is I put up a diagnostic review for you. And if you want, you can look at the diagnostic review. What we can't do, though, is I can't spend an entire semester teaching 119, 120 to you. You were expected to have that material. But if you need a review, go back and review. What are we going to do, though? We're going to start the course where the course deserves to start. Where does it deserve to start? In section 3. And that's going to be where we start. That's the jump now from Math 120 to 121. We're not going to do the review, but you may want to do that diagnostic review. You can do that. So I'm going to point out in the notes how they work. On your computer, you notice that the index, there's little red things over here. Anything that's in red will be clickable. So for example, let's say you come to class and say, hey, this guy's in section 3, go to the contents, click on section 3, and it'll bring you there. Let me explain how the notes are going to be structured. I'm not going to read it to you. However, if I were a student in this class, this is what I'd want my notes to look like. And I'll be honest with you, not initially, but over time, what I'd learned to do was type things up. You also want to get that skill set. So what I did was I typed up a typical set of notes that a student should have for my class of Math 121. Like if I were at the board, when I first started teaching, this is what I'd be writing at the board. It would be chicken scratch at the board, but all I did was I typed it up for you. So this is what my notes would look like if I were a student in the classroom. So I would claim, we'll talk about the notes. I'll go through it. I'm not going to read it to you verbatim, but we'll look at it. We'll go through some examples. I want to point out the notes when I go through example, in the blue area is typically me doing work. Now, my work might look substantially different than when I go to the whiteboard, but here's the deal. I would recommend reading through my work, but you'll see me talk through it. I'm just not going to read it to you verbatim. I'll talk through it though. And you'll see me work through problems. All right. One after another. There'll be another example here. Again, you'll see me work through the problem. All right. You'll see me answer questions. You'll see me work through the questions, yada, yada, yada. And then what happens? After lecture, I'll stop and then we'll come back and we'll do examples. I'll go through the examples one at a time. As we do this, I want to point out, you'll notice on the side, I have a lot of these embedded videos. So someone's going to say, well, you know what? During class, I was spaced out. I mean, I was thinking about something else, and I didn't hear a word he said about example number one. Well, what you could do, instead of watching the entire lecture again, which you can when I publish them, you could look at this link over here and click on it. And what's going to happen? A video will open up that's not very long that will go through that. Let me just briefly go through that. If you want to look at that video, it's 2 minutes and 5 seconds for that example. You can expand the window and you could play the video. I'm going to start it, but I'm not going to finish it. Okay, they want you to compute the delta y delta x on this given interval over here. All right, I'm going to stop that. Let me repeat this. I'm still going to go through the lecture, right? And then I'm going to do the examples at a whiteboard or at the blackboard. We'll go through all the examples. Someone says, well, you already did it already. Why do you need it again? It's not me needing to do it again. It's me needing to present it to you. So when you start thinking about doing problems on your own, that is after you attend the lecture, attend the example sessions, and study that material, you want to say, hey, can I do that? Can I try? Our goal at Essex County College is to promote you trying things. We would love for you to try. So what do? I have a bunch of homework questions for you to try. Someone says, oh, there's videos here. You know what? You can watch these little videos over here, but they're typically going to tell you that you need to study the material. However, what I do at the end of this session, and this, when I finish 3, I will pump online me doing the homework at the whiteboard. I'll pump that up. It'll be there. Now, where's that? On the website. You'll see that. If you're confused after me going through all this stuff over here, spending a lot of time on it, you need to reach out to me during office hours so we can understand where you're having troubles. Now, your troubles may be you don't have the prerequisite skills. We can tell you where to go to shore up on skills. Look, let's say you didn't really take Math 120, but you want to go back and learn it. We have a website for you to go to where you could actually learn 120 on your own. Now, we don't recommend doing that. We recommend taking 120 and responsibly taking it. That means study, 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 study. Okay, let's talk about the amount of time we spend. In class, we spend roughly 4 hours per week. Then you say, what's my obligation? Well, at a typical standard college, you would expect it, if you're well prepared, that is, you're prepared to take the class, you're expected to spend 3 times the amount of time that you're in classroom on study. So if you're in class 4 hours per week, that would require 12 hours per week of study time. Now, a lot of people look at that and say, I'm not doing that. We can't force you. Here's the problem though. What you don't realize is this. There are many people putting in far more time. That's who you're competing against when it comes to the job market. Who's getting those nice jobs? The people that put in tremendous time. Now, somebody says, no, it's all about talent. You're right. If you're highly talented, you're going to get a good job. Most people are not highly talented. What differentiates them is the amount of hard work they put in. And we're going to promote that. We really are. So what I'm going to do now is we're actually going to start lecture now. So where do I start lecture? At 3. Someone says, how do you do that? What I do is I switch. Give me 1 second, drop my pencil. I switch over to a whiteboard. And let me do that now. And you're going to see me do this throughout the semester. So this is the lecture part. Let's take a look. I'm going to say new share. I'm going to share my whiteboard with you. Give me a moment. And you're seeing my whiteboard now. Now, what's nice about a whiteboard, I can actually, talk about the notes now as if I was at the blackboard. So what I'm going to claim over here, looking at it, they're talking about concepts over here. Not that I want to read things to you, but initially the first lecture might be a little bit slow for you. Over time, I get a little bit faster. But I'm going to tell you what this section's about. This section's all about tangents and secants. We would love for you to read. We really would. All right. Not only read my notes, but read the textbook you have access to. Okay. So it says the idea of a limit is central to calculus, and an intuitive grasp of this concept is essential to further study. Initially, we'll examine two special types of limits, tangents and velocities. So I'm going to point over here is that, beginning parts of calculus, we're very much concerned about tangents and velocities. These two limits give rise to a central idea in differential calculus, and that's the concept of a derivative. We'll get there, not today, but we'll get there. The word tangent is derived from the Latin word tangens, which means touching. Someone says that's a rather imprecise word, touching. Thus, a tangent to a curve is a line that touches the curve and has the same direction as the curve at the point of contact. For a lot of students, that's a rather bizarre statement. They don't know exactly what that means. So what I want to do is I want to zoom in, and I'm starting to see there is a curve. I'm seeing the curve, and I'm seeing a line, and I'm actually seeing a line that appears to be tangent to the curve in this region over here. Now, what does that mean? It appears to be touching or appearing to be just like the curve in that region. Now, of course, it doesn't always stay next to the curve because it's a line, and the curve is a curve. All right. So we're talking about that tangent line. Now, I'm going to say, we'll keep reading it, but it appears the point of tangency is the point here. What's that point over there? It appears to be 5, comma, I'm sorry, I made a mistake there. It appears to be the point 0 for X, 5 for Y. Now, what I want to look at, and I'll go back to reading it later, I want to look at the slope of that line. Now, where'd you learn about slope? The slope of that line you learned about in Math 100 at Essex College. So I'm going to write the slope of that line. That's a line, right? And it's a tangent line. So I'm going to say M tangent. And this is me looking at a picture, by the way. We provide good pictures for a reason, by the way, so you can read them. The slope is definitely negative. And what's the rise in that? Well, let's take a look at it. And when I'm doing this over here, I need a rise and a run to do it. So I'm going to say, I'm going to use this thing as the rise, and that's going to be 5 units, right? What's the run? It looks like 2.5 to me. So I know it's negative. So I put this over here. So I'm going to say the rise, that's the delta Y, is 5 over the run, which is 2.5. All right. So then the question is, can I do that arithmetic? And it looks pretty simple to me. So I can say -2. So what's the equation of this tangent line? The equation of this tangent line. Well, I'm going to go back to what you learned in Math 100. That was y minus y1 equals m x minus x1. Y minus, what's y1? This is the point, 5. What's m? M appears to be -2. X minus, what's the x? It's going to be 0. Well, let's see if we can write that down. It looks pretty simple. What do you get? Y equals -2x plus 5. So I'm going to claim over here, what they did was they wrote that down for you. I'm verifying that by looking at my picture. What else did they put down? Well, something you learned in Math 119, you learned how to graph cubics in 119. And someone says, oh, you already did it for me. But the graph of this one over here, I'll outline it for you. The graph of this thing over here, somebody was kind enough to do that for me. That's a cubic, and that cubic looks like this over here. Oops. That's the cubic. All right, let's go back to the line, and we're going to talk about it again. Over here, when you zoom in over here, you should notice the line and the curve really look identical, but they aren't always identical. So over here, you notice that they move apart. You can see that moving apart over here, right? There's two things over there. Over here, they're moving apart. But I got to be honest with you, within a local region, they appear to be the same thing. That's what we mean by tangent. They're taking on the same characteristics in a very small region. All right. Now, does this line go through the curve at another point? It does. It's right over here. This is why we're also going to call this a secant line, because it goes through the curve at two distinct points. A confusion a lot of students have, though, is this, and the confusion is over here. We are not claiming that this is true that at any other point than at the 0.05. The problem for us, though, is differentiating between the line and the curve. Looking at this picture is almost impossible. However, they only touch one another in this region at the 0.05. At no other place are they touching in that region. Does it appear they're on top of one another? Yes, it does. But they're really only touching at 0.5. It's a grazing. All right. That's tough to comprehend. I know that. That's very difficult to comprehend. But I'm going to say for the most part, that's not bad. We got that covered. All right. Let's take a look. Next problem. Next problem, also relatively simple. But I got to be honest with you, we're going to go beyond simple, but I want to read it to you. So let's take a look at a simple example. And this is a simple example. Got a nice picture over here. What am I noticing? I'm noticing a line. They claim the line is tangent to the curve y equals x squared at the 0.11. Well, I'm going to kind of blow this up, and I'm going to put the 0.11 down for you. So 1, and again, I'm ballparking. I know sometimes it's hard, but I'm going to ballpark where 1 is. I'm going to say over here, this is the 0.11. All right, let me repeat this. When I blow this up, it looks like the line and the parabola are touching at more than 1 point. But I'm going to tell you now, they are not touching at more than 1 point. They're only touching at 1 point. Now, why does it look like they're touching more than 1 point? It's an artifact of the drawing, but they're only touching at 1 point. This is a tangent line. Where is it only touching? At the 0.11. They're touching nowhere else. Now, what do I have to do? I've got to look at this thing. And what I'm going to claim over here, looking at it, I can get right down the equation of the tangent line just by looking at this thing. And why is that? What's the equation of the tangent line? Y minus y1, which is 1, equals m tangent. I don't know what that is yet, but I'll get it in a second. And then it's going to be x minus 1. That's the point of tangency. I read that. Now, what I want to do is I want to talk about how to get a rise and a run. So what I'm going to do is I'm going to draw a triangle through some nice simple points to get the rise and the run. Right triangle. This is the run, and this is the rise. Clearly a positive slope. What is that? Well, looking at the picture, it appears to be a run of 1 and a rise of 2. So I'm going to say this tangent line is y minus 1. The slope of that line is 2, x minus 1. I'm going to simplify that and say it's y equals 2x minus 2 plus 1, which is y equals 2x minus 1. And that's right over here, that line. So someone say, I'm good. I can do that. Here's the problem. Generally speaking, this is very difficult to do unless you're given very accurate, simple pictures. So we need another method to do it. And we're going to go through that now. The other method is going to be this. We're going to take a line called the secant through that point, but through another point on the curve. So I'll put a point over here. Now, if I drew this secant line, it would look like this over here. And this is the secant line. This is secant line. What I want to do is I want to write down what m secant is. Well, I know a 0.11 on it, but I wonder what this point is over here. And someone says, oh, that looks about a quarter to me. But what I'm saying is, I don't know exactly what that number is. So I'm just going to simply say it's x, comma. Well, it's going to be a tough part. What's the y value? Well, if you look at it, the y is equal to x squared. So write slope down. Where'd you learn slope? In Math 100. So what's it going to be? The change in y, that's going to be 1 minus x squared. I'm doing this minus this. What goes on the bottom? 1 minus x. All right, let me write this down, what you've done in 092. 1 minus x times 1 plus x over 1 minus x. Right, not so bad, right? So what are you going to do now? Well, you know what I want to do? I want to take this point here, and I wanted to move it towards that point over there. But for me to compute slope, what do I know about it? I can't hit that point. So what I'm going to say is if I'm moving this thing over here, it's going to get closer and closer to the tangent line, but I don't want to hit that point. I just want to get arbitrarily close to it. That's a concept that you need to understand. But what I'm going to say is now is, and I'll write this on the side for you. I want to take that x, I'll write this in black now. I want to take the x and I want to move the x towards 1. Here comes my problem. I'm not exactly sure where x could be, but I want to claim over here, x could have also been over here. So what I'm going to claim is you're going to approach the number 1 from both the left and the right of it. Left side, right side, we're approaching the 1. I got to be honest with you, if you're going to approach 1, you're never going to never let x equal 1. And why is that? Well, for 1, you'd have division by 0, and 2, you couldn't compute slope. All right, let's write this down. This equals, if x is not 1, this would equal 1 plus x. So I'm now going to say this over here. mc is this thing. What I want to do, I want to make some tables up for you. X, mc X, mc I want to do a left table. And I want to do a right table. All right. What's a good number to the left of 1? Some people are going to say 0, and I agree. 0 is to the left of 1, but I want to get close to 1. And what's a good number close to 1 but to the left? I'm going to say a good number for me would be 0.9. Now, someone could say, could I get closer? And I can. I would say 0.99. Can I get closer? Yes, 0.999. Now, what I'm going to claim over here is this is getting close to 1 from the left side. We have notation for that, and we put a little minus sign over here. That does not mean negative numbers. That means from the left. We're getting close to 1 from the left side. Now I want to do a right table. What's a good number to the right of 1? I'm going to say 1.1. What's the number to the right that gets closer? Maybe 1.01. How about another number? 1.001. What am I going to say? This is getting close to the number 1 from the right side. That plus sign does not mean positive. It means to the right. Make sure you get your left and right covered. Now, of course, I got to compute mc. Someone can say, could I compute it here? Yes, you can. Could you compute it here? Yes, you can. Can you compute it here? Yes, you can. What's the easy one? This is easy. And I'm going to recommend, please try to go for the easy one. What do you get over here? 1.9, 1.99, 1.999. Do you know where this is going? Well, I think it's going towards 2. Let's do the other one. 1.1 plus 1, 2.1, 2.01, 2.001. Okay, what I'm going to claim is the left table, I'm looking at it, 1.9, 1.99, 1.999. It's definitely approaching 2 from beneath it. And this one is approaching 2 from the top of it. all right? So what I'm going to say over here is I am pretty much convinced that this is getting close to the tangent line. So as x goes towards 1, right? And we did that over here with the tables. I now can conclude from my table that m tangent is equal to 2. Now, did we know that looking at the picture? We sure did. We already knew that. All right. So over here, you notice I go through that work for you. I do write it up for you. I go through that work, and I wrote it up for you. All right, let's do the next one. And the next one is going to be, it's basically just a reading. That's all it is. Oh, but I want to point out, when I did this problem, I did say 2x minus 1 looking at the picture. All that work, I got the same thing. All right. Same exact thing. All right, let's put this one over here. And by the way, I'm not saying this is going to be easy for you. What I'm saying is it would be nice if you could think through and in stages and steps, go to the next step. So I'm looking at this over, it says, the time, this time we'll look at a function that has units on it. Well, before you had no units. Suppose an object dropped from a platform 400 meters above the ground and its position s in meters above the ground, t in seconds. So I'm going to say, I'll write this down for you. It appears that this is time, and the unit of time is seconds. So if I were to look at this, I'd say, 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. You get the idea. These are all seconds. And what's over here? I'm going to say this looks like it's a distance problem, and these are in meters. Let me write this over here. So this is going to be S, and S is going to be distance, and that's going to be in meters above the earth. Let me go through that with you. This is 0. That means it's not above the earth. It's on the earth. 100 meters above the earth, 200 meters above the earth, 300 meters above the earth, 400 meters above the earth. What did they say? At time 0, it would be 400 meters above the earth. Well, I'm clearly seeing that. And what else do I see? This is a parabola. It's a parabola. What's a parabola? It's a parabola that opens downward. So I'm going to put the picture of that in, and I'm going to say it looks like this over here. What happened over there? It hit the ground. Now someone says, oh, it hit the ground at 9 seconds. I'm not saying that, by the way. I'm just saying it looks about 9 seconds. It hit the ground at 9 seconds. Right, now what do I say? I see a tangent at the point 5. How do I know that? I'm reading that. So let me go up here. I'm going to put that down for you. About when I put these things down for you, I'll say it's a ballpark figure, but I got a function here, and I'm going to go through that with you. So I'm going to say, if this is 5, I would like to know how high it is up. Now, what some students will do, they'll do this. They'll say, oh, I think it's this number over here. And they'll say something without thinking about that they can compute that. So I want to write this down for you. It's going to be tough, but I want to write it down for you. You should be able to do this without using a calculator. So I want to compute this thing over here. Now, when I do arithmetic, it may look different than yours, but it should have the same result in the end. So S of 5, what's that going to be? Minus 4.9 times, what's 5 squared? 25, plus 400. I know it's tough, but I want to go through it with you. All right, so I'm going to do this first. I'm going to do the 4.9 times 25. I know it's negative, by the way, but I'll go through it with you. Let's see, 5 times 9 is 45. 5 times 4 is 20, 24. Let's see, 2 times 9 is 18. 2 times 4, 8, 9. Let's see, 8 and 4 is 12. All right, so what do I get here? I'm sorry, I made a mistake. I wasn't thinking. I do that. I daydream sometimes, and when I daydream, I really make. But yeah, I'm glad I catch my errors though. It's minus 122.5 plus 400. right? I got to do that. I got to look at my picture too, by the way. So I got to take the 400 and I got to subtract 122.5 from it. Oh boy, that's going to be something, right? 277.5. Let me see if that's true. 5, 110. Yeah, I'll put that in. 277.5. Let me go over here and write that number down. I know it's tough. We can't say this enough times. We are actually trying to encourage you to try though. All right. So someone can say, could you get the slope of that secant line? Well, this is getting more difficult for me, but I could ballpark it. I know it's negative. I could draw a triangle in. I know that much. But I want to see if I can do what I did before, which is do that secant business. I put it over here. I'll put a point here. I'm going to draw a secant line now. And what's this point going to be over here? Let's write this down. It's going to be a secant line, right? It's going to be work though. And so I don't like doing work. We want you to do work. So what's it going to be? T, and then it's going to be 400 minus 4.9 t squared. So I'm going to write down m secant now. It's going to be work though. Don't panic. All right. Let's do the change in y's. 400 minus 4.9 t squared minus 277.5 over, oh, it's going to be a tough one, t minus 5. Oh, I got to do it now, don't I? Let's put this down. Just like we did before, but are things getting more difficult? Yeah, they are. Let's see what we get. 122.5 minus 4.9 t squared. Let's keep going. You know I want to simplify, right? I'm going to factor out minus 4.9 t squared minus, well, let me write this down for you. I don't know if I can do it. So I'm going to divide 4.9 into 122.5. Well, that's like 49 into 1,225. Well, I'm going to see if I can do that. I'm going to say 2. 2 times 49, what would that be? 80 and 18, 98. And then what I got to do, I got to subtract, right? So it's going to be 24. I'm going to say 5. Let's see what happens. It might be a miracle. Who knows? 5 times 9 is 45. 5 times 4 is 20, 24. Wow, that's a miracle. Minus 25. I'm going to keep going. I know it seems crazy, but we can keep going until we see what we want to say, which I want to see something simple. Yeah, it's a lot of work, isn't it? What do I know? Let me go back to my original picture. Well, I know this. I want to move this point close to that one. So if there's anything I know, it's not going to be 5. T is not going to be 5 and move it close to that. It can get close, but it's not going to hit that point. All right, so let me go back over here. Oops, sorry about that. Let me just undo that. I'm sorry about that. And these are big, long blackboards here, aren't they? And did I move something? Oh, I got to write that down. I must have moved something around here. This is MC Kent. Whoops. I'm going to write this down. T is not 5. If that's not 5, what's this going to be? Minus 4.9 times T plus 5. All right. What are we going to do now? I want to get close to 5. So let me put this down for you. This will be the number 5. This will be from the left. This will be from the right. Don't be discouraged. You're looking. That's all we're doing. I'm going to make a left table. T from the left. What's a good number to the left of 5? I'm going to say 4.9. What's another good number from the left? I'm going to say 4.99. I want to get closer, right? 4.999. I'm going to do right. T. I'm going to say 5.1. That's to the right of 5, right? 5.01. 5.001. Now someone can say, what do you put on the other side? MC Kent. This is MC Kent. And this is MC Kent. What do you think might be easier to use? I think this is going to be the easy one. However, if you want to strengthen your arithmetic skills, you can do this one. But I think this one is going to be tough. But I'll tell you one thing. This and this will be in 100% agreement. I'm going to use easy though. Let's write this down. Minus 4.9. And what's 4.9 plus 5? It's going to be, let's see, 9.9. Minus 4.9 times 9.99. Minus 4.9 times 9.999. Let's do this one. I didn't do the computation yet. I'm just writing them down. This is going to be minus 4.9. Now let's see, that would be 10.1, right? Minus 4.9, 10.01, minus 4.9, 10.001. Well, you know what? I'm not going to do those computations. I'm just going to say where they're going. Where's this going? It's going towards 5 from the left. Where's this? Whoops, sorry about that. I think I lost track of where I was going. Where's this one going? 5 from the right. Where's this one going? I'm not going to compute those numbers. Why is that? I'm looking at it. It looks like it's going to minus 49. It does. It looks like it's going to minus 49. Where's this one going to? It looks like it's going to minus 49. How do I know that? Look at these numbers, 9.9, 9.99, 9.999. It looks like it's going towards 10 times minus 4.9. Where the other one's going, 10.1, 10.01, 10.001. Looks like it's going towards 10. I look, I did pretty good over here. So what I'm going to say, M tangent is minus 49. Now I realize a lot of students, they're absolutely befuddled by what that means. So what I want to do is I want to go back to the picture and talk about it. So I'm going to talk about the slope of the secant line, which is, I'm sorry, the slope of the tangent line, M tangent, is minus 49. And so it says, I wonder what that means. Well, that's going to be the delta S over the delta T. That's slope, right? What's the unit on S? Meters. What's the unit on T? Seconds. Meters per second. All right, we're going to look at the key now, see how we did. I want to read again the question to you. It says over here, clearly this parabola, we have a tangent line, approximate the slope. I got it, minus 49. Let's take a look at it. Oh, I'm sorry. Let's go through the questions. What's the unit of slope, meters per second? We've already answered that. What's sine of slope? Negative. We already answered that. I went through this business over here. I got the minus 49. We've already answered that. What's a tangent line? I have not answered that. I'll put that down for you. I know a lot of people want to put this down. Let me go back to this page over here. A lot of people want to put this down, y minus y1 equals m, x minus x1. They would be wrong. And the reason for that is this has nothing to do with x and y, but it's to do with s's. So it's going to be s minus s1 equals m tangent t minus t1. All right, let's go through this. I know it's tough, but I have to write it down for you. S minus, what's y? 277.5. We'll check it later. That's coming over here. That's the point. What's m tangent? Minus 49. T minus 5. All right. By the way, this is a fine answer. However, a lot of times people want to solve for S here. Let's write that down. Minus 49 T. Oh boy, that's going to be what? Plus, right? And then what are you going to get? That's 245. And then we're going to get plus 277. And S equals minus 49T. I have to add these together, by the way. Let me put this down, 277.5. And I want to point out, I'm not beyond making a mistake, and you're going to see me make mistakes throughout the semester, but I want to point out there's a learning experience. If I make a mistake, I'm going to correct myself. I really am. All right, 12. Let's see, 8, 12. Looks like 5. I'm going to go to the next page. I'm going to copy it. I want to make sure you know what I'm doing over here. I'm going to copy the answer. And we're trying to teach you over at this point what you need to be doing. What you need to be doing is looking carefully what we say the answers are and seeing if you got the right answer. All right. So I'm going to make sure you know that I wrote this stuff down. I'm going to use my red pen. So I'm going to say, do I have this one down? I do. It's right here. S minus 277.5 minus 49 times T minus 5. Did I write the other answer down? I think so. S equals minus 49T, 522.5. Everything is looking good. All right, it's looking good. All right, let me go to the next page. And I want to tell you where we are now. We're right here. We just verified that, right? Let me go 5. What's the instantaneous rate? We've already answered that question. It's going to be minus 49 meters per second. And that answer is written over here, by the way. Let me point this out to you. Minus 49 meters per second. We've answered that question already. That's the instantaneous velocity. So what did we introduce today? Concepts. Concepts that we need to reaffirm by doing examples. But right now, this is typically an interface we're going to face throughout the semester. We have lecture. And then we have examples. And they're going to be separated. All right. So lecture, example, lecture, example. Of course, here's the problem. Lecture, example. And then what happens is you need to study not only the lecture and the examples. You got to study both of those, but you're also going to have to work problems on your own. And that's where homework comes in. Let me repeat this. Your objective is to follow what we're doing in lecture. Although difficult, you need to follow that. We go through the course and we have a schedule to meet. We're going to meet that schedule. You need to put the required time in, which again, I'll tell you the university requirements. 4 hours of classroom activity would be 12 hours of study time outside the classroom. Yep, that's what's required. Do most students do that? Absolutely not. A lot of students actually will show up to exam doing little to no work. They're in a hamster cage. They don't know they're in a hamster cage. They keep repeating the same nonsense over and over again. And that's a nonsense of failure. If you work towards a goal of doing this material and you have the prerequisite skills, you'll have no problem getting through this course. It's not difficult. It's not rocket science. It really isn't. All right. So I'm going to say that's done. And then next time we come back, we'll do the examples. All right. Thank you.